Annyeonghaseyo, engineers of the future. This is your online class in engineering economics. Welcome, welcome. I am Daryl J. Amblebeen, your lecturer. In this video, I will discuss present economic studies. Specifically, we will solve sample problems in this topic. I assume that you already had an initial read of the lesson posted in our previous meeting. Ano pang hinihintay mo? Tara! Present economic studies involve the analysis of problems for manufacturing a product or rendering a service upon the basis of present or immediate cost. They usually occur when the effects of time such as interest and depreciation are negligible. Therefore, we will not consider interest and depreciation. Present economy analysis is employed when the alternatives to be compared will provide the same result and the period of time involved in the study is relatively short. Present economic studies occur in the following situations: selection of material, selection of method, selection of design, site selection, comparison of proficiency of workers, economy of tool and equipment maintenance, and economy in the utilization of laborers. Rules for selecting preferred alternative. First, when revenues and other economic benefits are present and vary among alternatives, choose alternative that maximizes overall profitability based on the number of defect-free units of output. Second, when revenues and economic benefits are not present or are constant among alternatives, consider only costs and select alternative that minimizes total cost per defect-free output. Example on selection of material. In the design of a jet engine part, the designer has a choice of specifying either an aluminum alloy casting or a steel casting. Either material will provide equal service, but the aluminum casting will weigh 1.2 kilograms as compared with 1.35 kilograms for the steel casting. The aluminum can be cast for 80 pesos per kilogram and the steel for 35 pesos per kilogram. The cost of machining per unit is 150 pesos for aluminum and 170 pesos for steel. Every kilogram of excess weight is associated with a penalty of 1,300 pesos due to increased fuel consumption. Which material should be specified? And what is the economic advantage of the selection per unit? First, let's consider the cost of using aluminum metal for the jet engine part. From the problem, it is given that the weight of aluminum casting per unit is 1.2 kilograms. The cost of making aluminum casting is 80 pesos per kilogram. And the cost of machining aluminum casting per unit is 150 pesos. Now let's compute the total cost of jet engine part made of aluminum per unit. You do note that the solution should be consistent with per unit. This is then equal to cost of making aluminum casting per unit plus cost of machining aluminum casting per unit. The cost of making aluminum casting per unit is equal to the product of the cost of making aluminum casting and the weight of aluminum casting per unit, which is equal to 80 pesos per kilogram times 1.2 kilograms. You will notice that here, the kilogram will be cancelled. Plus 150, which is the cost of machining aluminum casting per unit. Using your calculators, you should get the sum of 246 pesos as the total cost of jet engine part made of aluminum per unit. Next, let's consider the cost of jet engine part made of steel per unit. Again, from the problem, it is given that the weight of steel casting per unit is 1.35 kilograms. The cost of making steel casting is 35 pesos per kilogram. The cost of machining steel casting per unit is 170 pesos. And the penalty for excess weight of steel casting is 1,300 pesos per kilogram. Now let's compute the total cost of jet engine part made of steel per unit. Again, per unit. It is equal to the cost of making steel casting per unit plus the cost of machining steel casting per unit plus penalty for excess weight of steel casting. You might ask, why is there an addition of penalty for excess weight of steel casting? The answer is because considering steel, that is 1.35 kilograms per unit. Comparing that to aluminum, steel has an excess weight, which we're going to compute. Substituting our values, again, the cost of making steel casting per unit is the product of the cost of making steel casting and the weight of steel casting per unit, which is equal to 35 pesos per kilogram times 1.35 kilograms, plus 170, which is the cost of machining steel casting per unit, plus, now we're going to compute for the penalty for excess weight of steel casting, which is equal to the product of the penalty of excess weight of steel casting and the excess weight. So the penalty of excess weight of steel casting is 1,300 pesos. And the excess weight is simply the difference between the weight of steel casting per unit and the weight of aluminum casting per unit, which is 1.35 kilograms minus 1.2 kilograms. Using your calculators, you should get the sum of 412.25 pesos as the total cost of jet engine part made of steel per unit. So what is our decision? The total cost per unit of a jet engine part made of aluminum is less than that for an engine made of steel. Hence, aluminum is suggested for making the jet engine part. We choose aluminum, therefore. For the second question, the economic advantage of using aluminum over steel per unit is simply the difference between the total cost per unit, which is equal to 412.25 pesos minus 246 pesos. Using your calculator, that should be equal to 166.25 pesos. So these are our final answers. Example on selection of method. An industrial engineer has two alternative methods in accomplishing a production job. Both methods involve the acquisition of the same working place and other capital equipment to be used for this job only. Method A calls for a crew consisting of 3 men, each costing 30 pesos per hour. This method will result in the production of 10 units per hour, of which 2 will be rejects. Method B calls for a crew of 2 men, each costing 35 pesos per hour, and should result in the production of 8 units per hour, of which 1 will be reject. The cost of the direct material lost in each reject is 20 pesos. If a certain total number of units is to be produced, find which method is more economical. Let's compute the cost per unit in method A. First, let's compute the cost per hour, which is equal to the cost of the crew per hour plus the cost of the rejects per hour, which is equal to, for the cost of crew, 30 pesos per hour per man times 3 men. Therefore, cancel men. Plus the cost of rejects per hour, which is equal to 20 pesos per reject times 2 rejects per hour. Therefore, cancel reject. Using your calculators, we have, for the cost of crew, 90 pesos per hour, and for the cost of rejects, 40 pesos per hour. And the sum is equal to 130 pesos per hour. This is now the cost per hour in method A. Divide this by the number of units, which should be the non-rejects per hour. So let's divide 130 pesos per hour by the number of units, non-rejects, per hour, which is 8 units per hour. Therefore, cancel hour. And the sum using your calculator is, the quotient using your calculator is 16.25 pesos per unit. Let's compute the cost per unit in method B. Again, first we compute the cost per hour, which is equal to the cost of crew per hour plus the cost of rejects per hour. For the cost of crew per hour, we have 35 pesos per hour per man times 2 men. Therefore, we cancel men. Plus the cost of reject per hour is 20 pesos per reject times 1 reject per hour. Cancel reject. So that the cost of crew is 70 pesos per hour and the cost of rejects is 20 pesos per hour. Getting the sum, that should be equal to 90 pesos per hour. Let's divide this number by the units, non-reject, per hour. So we have 90 pesos per hour divided by the units, number of units, non-reject per hour, which is 7 units per hour. Cancel hour, and the quotient is equal to 12.86 pesos per unit. Now, what is our decision? Which method is more economical? Comparing method B to method A, method B is more economical because method B costs less than method A. Araso? Example on selection of design. ASUS manufactures 1 million units of netbooks yearly. A new design of the product will reduce material cost by 12%, but will increase processing cost by 2%. If material cost is 1.20 pesos per unit and processing will cost 0.4 per unit, how much can the company afford to pay for the preparation of the new design and making changes in equipment? The hint is the maximum amount the company should spend should not exceed the savings they will make on the new design, if there is any. How to compute for the savings? That is equal to the difference between the decrease in material cost and the increase in processing cost. First, let's compute the decrease in material cost, which is equal to the material cost per unit times the total units times the percent of decrease. So the material cost per unit is 1.20. The total units is 1 million and the percent of decrease is 12% or 0.12. Getting the product of this is 144,000. Next, let's compute the increase in processing cost, which is equal to the processing cost per unit times the total units times the percent of increase. In this case, that is equal to 0.40, the processing cost per unit, 1 million total units, and 0.02 or 2%, the increase or percent of increase. Getting the product of this is 8,000. To get the savings, we simply get the difference of these two. The difference is 136,000 pesos. And this is our final answer. Araso? Example on selection of site. A certain masonry dam requires 200,000 cubic meters of gravel for its construction. The contractor found two possible sources for the gravel, Isabela and Cagayan, with the following data. The average distance from gravel pit to dam site for Isabela is 3 kilometers. For Cagayan, 1.2 kilometers. The gravel cost per cubic meter at pit for Cagayan is 10 pesos. The purchase price of pit for Isabela is 800,000 pesos. The road construction necessity for Isabela is 450,000 pesos. The overburden to be removed at 4.20 pesos per cubic meter for Cagayan is 90,000 cubic meters. The hauling cost per cubic meter per kilometer for both Isabela and Cagayan is 4 pesos. Which of the two sites will give a lesser cost? First, let's consider the cost of 200,000 cubic meters of gravel from Isabela. From the problem, the purchase price of pit is 800,000. The road construction is 450,000. And the hauling cost is 4 pesos per cubic meter per kilometer. So we need to multiply 4 with the volume and length, which are 200,000 cubic meters and 3 kilometers respectively. So getting the product, this is equal to 2,400,000. Getting the sum of these three, we have the total cost for Isabella equal to 3,650,000. Next, the cost of 200,000 cubic meters of gravel from Cagayan. The cost of gravel at pit is 10 pesos per cubic meter. So we need to multiply 10 with the volume of gravel, which is equal to 200,000 cubic meters. The product of this is equal to 2 million. The removal of overburden is 4.2 pesos per cubic meter. We need to multiply 4.2 with the volume of the overburden to be removed. And for Cagayan, that is equal to 90,000 cubic meters. The product is equal to 378,000. And for the hauling cost, 4 pesos per cubic meter per kilometer times 200,000 cubic meters times 1.2 kilometer. The product is equal to 960,000. Getting the sum of these three, we have the total cost for Cagayan equal to 3,338,000 pesos. Now, the question is, which of the two sites will give a lesser cost? Obviously, the source in Cagayan is cheaper by 312,000. So our final answer is the source in Cagayan. Araso? Example on worker proficiency. An executive receives an annual salary of 600,000 pesos and his secretary a salary of 180,000 pesos. A certain task can be performed by the executive working alone in 4 hours. If it delegates the task to his secretary, it will require him 30 minutes to explain the work and another 45 minutes to check the finished work. Due to the unfamiliarity of the secretary to do the task, it takes her an additional time of 6 hours after being instructed. Considering salary cost only, determine the cost of performing the task by each method. If the secretary works 2,400 hours a year and the executive 3,000 hours a year. Compute first the cost of the executive and the secretary per hour. This is equal to the salary per year divided by the working hours per year. For the executive, the salary is 600,000 pesos per year divided by 3,000 working hours per year. Cancel year. Therefore, the cost of the executive per hour is 200 pesos. For the secretary, the salary is 180,000 pesos per year, divided by 2,400 working hours per year. Again, cancel year. The cost of the secretary per hour is 75 pesos. Now let's compute the cost of the executive working alone. This is equal to the cost of the executive per hour times the number of working hours. The cost of the executive per hour is 200 pesos times he works alone for 4 hours. Cancel hour. Therefore, the cost of the executive working alone is 800 pesos. But what is the cost if the executive delegates the task to his secretary? So you do note that in this case, both of them will work. First, the executive. The executive costs 200 pesos per hour, and he works 30 minutes to instruct his secretary plus 45 minutes to check the work of his secretary. Note that this is in minutes. We need to be consistent with hours. So we need to convert this minutes into hours by simply dividing by 60 minutes. Because in 1 hour, there are 60 minutes. We cancel hour plus the executive costs 75 pesos per hour times she works 6 hours plus 30 minutes to be instructed by his executive, by her executive rather. Note again that this is in minutes. We should be consistent with hours by dividing this by 60 minutes. We cancel again hours so that the cost of the executive delegating the task to his secretary is 737.50 pesos. So that is the cost for each method. Suppose we are asked which method should we choose? So obviously we will choose the second method. Araso? Example on equipment maintenance. A machine used for cutting materials in a factory has the following outputs per hour at various speeds and requires periodic tool regrinding at the intervals cited. For speed A, 200 pieces of output per hour, tool regrinding every 8 hours. For speed B, 250 pieces of output per hour, tool regrinding every 7 hours. For speed C, 280 pieces of output per hour, tool regrinding every 5 hours. A set of tools costs 1,800 pesos and can be ground 20 times. Each regrinding costs 18 pesos and the time needed to regrind and change tools is 1 hour. The machine operator is paid 28 pesos per hour, including the time the tool is changed. The tool grinder, who also sets the tools to the machine, is paid 25 pesos per hour. The hourly rate chargeable against the machine is 54 pesos, regardless of machine speed. Which speed is the most economical? Speed A has an output of 200 pieces per hour. This means that the pieces produced in 8 hours is equal to 8 hours times 200 pieces per hour, equal to 1,600 pieces. Now we compute the cost of production for speed A. The tool cost is equal to 1,800 pesos divided by 20. This is equal to 90 pesos. We divided it by 20 because 20 is the number of times the tool can be ground and we're only going to use the tool once. The regrinding cost is equal to 18 pesos because we're only going to regrind the tools once. The wage of machine operator is equal to 28 pesos per hour times 8 hours to operate the machine plus 1 hour to change the tools. This is equal to 252 pesos. The wage of tool grinder is equal to 25 pesos per hour times 1 hour to regrind the tools. This is equal to 25 pesos. The machine cost is equal to 54 pesos per hour times 8 hours, which is the operating hours of the machine. This is equal to 432 pesos. We get the sum of the 5 to get the total cost of production for speed A, equal to 817 pesos. Now we're ready to compute the cost per piece, which is equal to the total cost of production divided by total output, equal to 817 pesos divided by 1,600 pieces. Therefore, the cost per piece in speed A is 0.511 pesos. Speed B has an output of 250 pieces per hour. The pieces produced in 7 hours is equal to 7 hours times 250 pieces per hour, equal to 1,750 pieces. Now we compute the cost of production for speed B. The tool cost is still equal to 90 pesos. Regrinding cost, 18 pesos. What changes is wage of machine operator equal to 28 pesos per hour times 7 hours to operate the machine plus 1 hour to change the tools. This is equal to 224 pesos. Wage of tool grinder is still 25 pesos. Another change is the machine cost, which is equal to 54 pesos per hour times 7 hours, which is the operating hours of the machine. This is equal to 378 pesos. We get the sum of the 5 to get the total cost of production for speed B, equal to 735 pesos. Now we're ready to compute the cost per piece in speed B, equal to total cost of production divided by total output, equal to 735 pesos divided by 1,750 pieces. Therefore, the cost per piece in speed B is equal to 0.420 pesos. Speed C has an output of 280 pieces per hour. The pieces produced in 5 hours is equal to 5 hours times 280 pieces per hour, equal to 1,400 pieces. Let's compute the cost of production for speed C. The tool cost is still 90 pesos. Regrinding cost, 18 pesos. Wage of tool grinder, 25 pesos. The changes are the wage of machine operator and the machine cost. For wage of machine operator, it is equal to 28 pesos per hour times 5 hours to operate the machine plus 1 hour to change the tools. This is equal to 168 pesos. For machine cost, it is equal to 54 pesos per hour times 5 hours, which is the operating hours of the machine. This is equal to 270 pesos. Getting the sum of these 5 gives the total cost of production for speed C, equal to 571 pesos. We're ready to compute the cost per piece for speed C, which is equal to total cost of production divided by total output, equal to 571 pesos divided by 1,400 pieces. Therefore, the cost per piece for speed C is equal to 0.408 pesos. Now, what is our decision? Which among the three is the most economical? The foregoing comparative analysis indicates that speed C is the most economical. Why? Simply because speed C has the least cost per piece. Araso? Example on utilization of personnel. A building contractor has a contract which will expire in 30 days. He has 80 men on the job and can finish the work in 50 days. The wage per day of 40 men is 20 pesos, and that for the other 40 men is 18 pesos each. For 8 hours work per day, the fine or liquidated damages for delay in the work is 400 pesos per day. How much more men should the contractor add in order to enable him to complete the work on time? Assuming that the additional men will have a wage of 20 pesos per day, will the contractor save money by employing enough men to enable him to complete the work on time, or not adding men and paying the liquidated damages? How much is the saving, if any, assuming no overtime? First, let us compute the number of additional men needed to complete the project on time, denoted by variable x. To find the value of x, we equate the man days. That is, 80 times 50, meaning 80 men can complete the project in 50 days, is equal to x plus 80 times 30, meaning 80 plus additional men can complete the project in 30 days. X is now equal to 53.3. Rounding that up to the nearest whole number, we get 54 men. This means that in order to complete the project on time, 54 more men should be employed. Now, we consider if it's just 80 men for the job, meaning no additional men will be employed, but there will be liquidated damages because there is a 20-day delay of the project. First, let's compute the wages. For the first 40 men, that is 20 pesos per man per day, times 40 men times 50 days. We cancel men, we cancel days. Plus, for the other 40 men, that is 18 pesos per man per day times 40 men times 50 days. The sum of the wages is equal to 76,000 pesos. Next, as I've mentioned, the liquidated damages, which is 400 pesos per day, times the delay, which is 20 days. Cancel days. Damages is equal to 8,000 pesos. The total cost is equal to wages plus damages. It is equal to 84,000 pesos. So this is the total cost if 80 men is just considered for the job. The next scenario is, aside from the 80 men already in the job, another 54 men will be employed. This results to the completion of the project on time, within 30 days. Thus, there will be no delay of the project, and there will be no liquidated damages or fines. Thus, in this case, only the wages will be considered in the total cost. For the wages of the first 40 men, that is 20 pesos per man per day, times 40 men, times 30 days, plus the other 40 men, that is 18 pesos per man per day, times 40 men, times 30 days, plus the additional 54 men, that is 20 pesos per man per day, times 54 men, times 30 days. The total cost, therefore, considering 134 men for the job, is equal to 78,000 pesos. Now, what is our decision? Should we employ more men for the job or not? By employing more men, the contractor saves 6,000 pesos. Therefore, we should employ 54 more men for the job because we can save 6,000 pesos if we do so. At so, if you have questions about this lecture, you can always send a personal message in my messenger, or you can post your questions in our LMS forum. Thank you for your time. 감사합니다. Let me end this presentation with a quote from Maya Angelou. My wish for you is that you continue. Continue to be who and how you are, to astonish a mean world with your acts of kindness. Continue to allow humor to lighten the burden of your tender heart. Again, this is Daryl J. Amblebin, your lecturer. Until next time. Annyeong!